Hey Kipsters, today we're going to be working with lesson 11, constant rate. Please make sure you have your notes packet out and ready to move on with the lesson. At the top of my paper, I'm going to write down some previous knowledge from lesson 10. Remember, when I'm giving a specific distance and specific time, I can create a proportion to solve for that given time over my given distance. I want to set that equal to another given time over another given distance. We then know that the first step in solving a proportion is to cross multiply. So I multiply this given time by this given distance and set it equal to this given time times this given distance. And then depending on which of these on the right I don't know, that's the one I want to isolate. We also talked yesterday about this word, constant rate. Constant rate is equal to distance over time. Constant rate tells us the rate at which a person and or a thing consistently moves from one metric or one interval to another. We're going to take all of that knowledge and accomplish the objectives for today, which are to define constant rate in varied contexts and express two variables where t represents the time interval. And you're going to be able to graph points on a coordinate plane related to constant rate problems. Oh, don't forget, whenever we want to write a linear equation in two variables, we want to set our given distance and time equal to the variable y, which coordinates to distance, and x, which coordinates to time. Then we want to make sure that we isolate our y. So we're always going to get that y is going to be equal to over time x. Simple one. Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn in 2.5 minutes. What area in square feet can she mow in 10 minutes? What about in t minutes? In the first sentence, which measurement talks about my distance? Yeah, square feet is my distance. It's going to leave 2.5 minutes to be my time. So if I wanted to write the fraction that represents Pauline's constant rate at mowing the lawn, what would that look like? Pauline's constant rate would be her distance of 35 square feet over her time of 2.5 minutes. How can we use this constant rate to help us determine the area in square feet she can mow in 10 minutes? We can create a proportion. So I'm going to come out to the right, and I'm going to set my given constant rate of 35 square feet over time, and I'm going to set that equal to another ratio. Remember, 35 square feet represents my distance. Look at the question. Have we been given our distance? No, we haven't been given our distance, so we're actually going to use the variable y. But we have been given our time, so our denominator is going to be 10 to represent 10 minutes. I know the first step in solving a proportion is to cross multiply. I'm going to cross multiply these numbers, and I'm going to have that 35 times 10 is equal to 2.5 times y. At this point, I want to solve for this distance over 10 minutes. What do I need to do to both sides of my equation? What does y represent in the context of this problem? Yeah, this tells me that she mows 140 square feet in 10 minutes. So I've answered the first part of the question. But the second part of the question asks me, how many square feet can she mow in t amount of minutes? When I want to know any distance over any distance at any time, I want to create another proportion. This time in that proportion, I'm going to use my given time, 2.5 minutes. I'm going to put that over my given distance of 35 square feet. I'm now going to set that equal to the ratio that represents the any time over any distance. Notice I'm using the variables t and y. T represents time and y represents distance. I know the first step in solving a proportion is to cross multiply. I'm going to have that 2.5 y is equal to 35 t. My goal here is to create a linear equation in two variables. I do see a linear equation in two variables. Now I want to isolate one of those variables. Which variable do I want alone? Yeah, I want the y alone. So I'm going to divide both sides by 2.5. And I get that y is equal to 35 divided by 2.5 t. Again, I notice that 35 and 2.5 can be further simplified. So I'm actually going to get my calculator. And I'm going to do 35 divided by 2.5. And I get a simplified answer of 14. So y is equal to 14t. This is my linear equation in two variables. Let's use this equation to help us solve for some given time intervals. Make sure you've written your equation in the table just like me. What if I asked you what was the amount of square feet she mowed over 0 minutes, 1 minute, 2 minutes, 3 minutes, or 4 minutes? What could you do? Hopefully you said you could use this equation and substitute each given t into the problem, and you could find the area. Take a minute or two to complete the rest of this table, making sure to show substitution. Fill in your given areas. The completed table should look like mine. Now that I have a completed table, I notice that there's a graph directly to the right. I want to transfer this information directly to the right onto the coordinate plane. Before you begin plotting any points, you want to make sure that you explore your coordinate plane. I notice that my x-axis, my horizontal axis, is actually my t. So t and x are the exact same thing. I notice that my vertical axis is y, and it's called my lawn mowed in square feet. I want to now plot each of these ordered pairs on. I'm going to start at the origin. The origin is where the x and the y axis meet. And I'm going to go to an x of 0 and a y of 0. So I'm going to make my first point be right there. To plot my next point, I want to go to an x of 1 and a y of 14. Notice 14 is right below the 15 because I'm not counting by ones on my y-axis. Please plot the remaining points. The graph should look like mine. There are a few things we can conclude from this graph. From this graph, I can conclude that as time increases, distance increases. I can also conclude that the lawns were mowed at a constant rate because if I took a straight edge and attempted to connect my points, I would make a straight line through the origin. That's example 1. Let's give example 2 a try. Go ahead and get started on example 2 independently. Example 2 says water flows at a constant rate out of a faucet. Suppose the volume of the water comes out in 3 minutes is 10.5 gallons. How many gallons of water come out of the faucet in 2 minutes? Well, I know when I see constant rate, I want to annotate distance over time. I want to annotate the next sentence. Which of the given measurements represents my time? Which represents my distance? Yeah, you should have said that 3 minutes is my time, and that 10.5 gallons is my distance. Notice I'm using the variable v for this distance. How many gallons of water come out of the faucet in T minutes. I want to know any gallons in any time interval. I can do this by setting up a proportion. What does my proportion look like? My proportion should look like my given time, 3, over my given distance of 2.5. And I want to set that equal to time of T over distance of V. My next best step is to cross multiply. So I get that 3V is equal to 10.5 T. Which of these variables do I want to isolate to create a linear equation in 2 variables? I want to isolate the V, so I'm going to divide both sides by 3. And I get that V is equal to 10.5 divided by 3T. Make sure you write that equation in your table. And use this equation to substitute the given intervals of T and to determine the amount of gallons for 0, 1, 2, 3, and 4 minutes. When you're finished, all of these values should be recorded on your graph to the right. This is what your completed graph should look like. What are some things you can conclude based on this graph? Hopefully you said that as time increases, volume increases, and that we know that the water flows out at a constant rate, because when I connect all of my points, they can make a straight line through the origin. All right, take some time to work on exercise 1 independently. Please type your answers into the box and get them recorded on your packet. If you finish up with exercise 1, you can push into exercise 2. Don't forget to complete your exit ticket for this lesson. And I will be collecting this entire packet today. Again, I will be collecting this entire packet today, so make sure to give it to the show.